Welcome to Session 12, Quadratics by Factoring. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to place a quadratic in standard form before factoring, to choose among GCF, trinomial, grouping, and identity patterns, and to apply the zero product property without losing a zero solution. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. The area model connects trinomial terms to the side lengths represented by factors. Product and sum conditions must both hold. The corner product controls the split middle term, while row and column groupings reveal the two binomial factors. The key distinction is this. Place a quadratic in standard form before factoring. Then connect it to the second goal. Choose among GCF, trinomial, grouping, and identity patterns. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Move every term to one side so the other side is 0. Identify the object being changed and the requested result. Step 2. Factor out any greatest common factor first. Use a separate line so signs, units, and restrictions stay visible. Step 3. Select a pattern and verify by multiplication. Work efficiently without skipping an operation. Step 4. Set each complete factor equal to 0 and check both roots. Whenever possible, verify with evidence independent of the original working. Signal 1 is, every term shares a factor. Respond by remembering, remove the GCF first. Name the response before calculating. Signal 2 is two squares separated by subtraction. In that case, use difference of squares. The form tells you which tool fits. Signal 3 is, leading coefficient is not 1. Remember, use product AC and split the middle term. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve 6x squared minus x minus 2 equals 0. Restate the target and identify the most important part of the routine. The first move is, the product AC equals minus 12, use 3 and minus 4 because their sum is minus 1. This changes the form without changing the meaning. Next, rewrite 6x squared plus 3x minus 4x minus 2 equals 0. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. Brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Group 3x, 2x plus 1, 2, 2x plus 1, equals 3x minus 2, 2x plus 1. State what the transformed line tells you. Complete the argument. Thus, x equals 2 over 3 or x equals 1 over 2. This is part of the solution, not decoration. The final answer is x equals 23 or x equals 12. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. Factor x squared minus 25. Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. Focused hint. Recognize a difference of squares. Use it to repair your setup rather than guess. An accepted answer is x minus 5, x plus 5. Explain why it works and name the first step that would expose a common error. The central message is, place a quadratic in standard form before factoring. Combine it with the discipline to choose among GCF, trinomial, grouping, and identity patterns. Finish by remembering to apply the zero product property without losing a zero solution. This turns a calculated result into a justified answer. Reflection. Why must an equation equal 0 before using the zero minus product property? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 5 minutes, including multiplication to verify factors. Keep the work readable, check it independently, and carry the routine forward.